All right, I'm going to go ahead and do some examples from lines that intersect circles. So I have a diagram here, and I'm going to ask to find the diameter, the radius or radii if there's more than one, a chord, a secant, and a tangent. So I'm going to go ahead and highlight the diameter here. And diameter is a segment, so I would call that segment KM or segment MK. Direction doesn't matter. If I look at the radii, there's more than one. I can also take that diameter and split it in half. So I can go from L to K, or I can go from L to M, or I can go from L to J out here. So I've got segment LK is a radius, segment LM is a radius, and segment LJ is a radius. Okay, a chord is a line segment. Much like the diameter, it just doesn't go through the middle. So if I were to highlight a line segment here that goes from edges of my circle but does not go through the middle, I would do line segment JM. A secant, if I were to highlight, I would extend this line that goes on forever and cuts through my circle. So I would call that line JM. And then down here for my tangent, I've got a line that just touches the edge of my circle at one point. And in this scenario, I would call that line M. All right, example 2. I have two circles here that are tangent to each other. I'm asked to find the length of each radii, identify the point of tangency, and write the equation of the tangent line. Okay, so for the first one, circle D here, it's pretty easy to find the length of the radii. I'm just going to go either vertically up 3 units, or I can go down 3 units, or left or right. And it's pretty obvious that the length of that radius is 3 units. Don't be confused and try to go at an angle. That makes it much harder. You could find that that's 3 units, but you'd have to use a little trig and make right triangles. So we're going to say the radius of circle D is equal to 3 units. And then down below you can see that circle C here, 1 in all directions. So the radius of circle C is equal to 1 unit. All right, identify the point of tangency. I'm going to go ahead and make a dot, a blue dot, where these two circles intersect. And then I have to identify that dot as the coordinate point positive 2, comma, negative 1. The last question, write the equation of the tangent line. I'm going to go ahead and highlight this line. And anytime I have a horizontal line, my equation is a y equals equation. And in this scenario, it's y equals negative 1. All right, example 3, find x and y. The first thing I notice is that anytime I have two tangent lines that meet out at the common external point D here, I can go ahead and make tick marks here because those two tangent lines must be congruent. And then I have a simple algebra equation, 2x equals 16. Divide both sides by 2, and you get x equals 8. Okay, looking on to y. Now I'm dealing with the interior angles of this specific shape, and one thing I do have to know that if line AD is tangent to this circle, then angle A here must be perpendicular, must be 90 degrees. And the same thing down below. If CD is a tangent line to this circle, then angle C here must be perpendicular. Now, I'm going to go ahead and look at this specific shape right here, this quadrilateral. And I'm going to jump ship from the circles. I'm not worried about the circle right now. And one fact we know about quadrilaterals are the interior angles must add up to 360. So then I just do 360 minus one of the 90-degree angles, minus the other 90-degree angle, minus the 38 given angle, and I get y equals 142 degrees. Okay, example 4. Very similar problem. You'll notice you have this external point A. You've got these two tangent lines. Kind of looks like a dumped over snow cone or ice cream cone. I can go ahead and add tick marks because I know from A to C must be congruent from A to B. Now I have equation 3x squared equals 15x. Now this problem might look confusing at first because It's got x squared in it, and you're worried about quadratics, but I can use simple division here. Divide both sides by 3x. And on the left here, my 3's cancel. One of my x's cancel. On the right, my x's cancel. And I get x equals 5. Now, I can check my work, or if they ask me to plug it back in, on the left side here, I could do 15 times 5 is 75. And on the right, 3 times 5 squared is 25, and 3 times 25 is 75, so it works out. All right, example 5. This is a great problem, a little bit tricky here. You're asked to find the length from S to T. Now, in order to get this started, you do have to know something about how a radius works. A radius from Q to any point on this circle has to be 12 all the way around. So I'm going to go ahead and make the radius run up to point R up here. And now I have a right triangle where one of the legs is 12 and the other leg is 35. And if I have a right triangle, I can always use the Pythagorean theorem. A squared plus B squared equals C squared. So I'm going to go ahead and plug in the legs there. Go ahead and add those up. I get 1,369, square root both sides, and I get C equals 37. So if the length from Q to T is 37, and now it's a pretty simple math operation, I just subtract the part from the whole, 37 minus 12, and I get the length from S to T is 25. And I know if Q to S is 12 and the whole length is 35, then from S to T must be 25.